Section 1.6, Gaussian elimination. The objectives are to write the augmented matrix of a system of equations and write the system of equations from an augmented matrix, perform row operations on a matrix, and finally to solve a system of linear equations using matrices. So we mentioned this word augmented matrix a few times already in the objectives. So what is an augmented matrix? We already know that systems of equations look like this. They are going to consist of multiple equations with multiple variables, some equal signs somewhere. Turns out that we can take these types of equations and systems and rewrite them in matrix form. Now, because the matrix will have some coefficient values and some random numbers that didn't have any variables, we typically like to call that an augmented matrix rather than just a matrix. So the first task is how to translate one of these linear systems into an augmented matrix, and the process is described in this procedure right above the example. But the bottom line is you want to make sure that all the x's are lined up on the same column, then all the y terms are lined up in the same column, make sure that all the equals are lined up, and finally put the numbers that don't have any variables on one side of the equal sign. So in other terms, if I have a system of equations which consists of the equations 4x minus 3y equal to 11 and another equation 3x plus 2y equals to 4, I can take this system and turn it into an augmented matrix, and the matrix for this problem will look like 4, then -3, then 11, then 3 and 2, followed by finally 4. So we just grab the coefficient of the x terms, the coefficient of the y terms, and all the numbers that were after the equal sign. First, make sure everything is lined up correctly, then grab the numbers, and then grab the other numbers, and so on and so forth until you're completely done with the whole process. So repeat this as many times as needed, depending on how many variables you have in your problem. Now, to make it into a matrix, we'll add the square bracket at the beginning, we'll add a square bracket at the end, and because this is an augmented matrix, we will put a slight line right here, a vertical line between the second and the third column to remind us that this is where the equal sign used to be. So 4 and 3 are the x values, the -3 and the 2 were the y values, and these were just the numbers that didn't have any variable. And so what's the size of this matrix? The size of this matrix is a 2 by 3. So the order or the size or the dimension represents how many rows and how many columns we had to begin with. And in this case, it's a 2 by 3 matrix. So that's how you write an augmented matrix. Very straightforward process, very simple, not much to it other than organizing yourself first. So we'll practice how to do this again. So on the second problem, we have the matrix, or we have the system x plus 2y minus z. So let me write it down, x plus 2y minus z equals to 3. Then we have 2x minus y plus 2z's equal to 6. And finally, we have x minus 3y plus 3z equal to 4. This is the given system. First, make sure that all the x's are lined up, then all the y's are on top of each other, all the z's are lined up, and then finally all the numbers after your equal sign. Once you have made sure that everybody is correctly lined up, you're going to turn this into an augmented matrix. And all we need is the coefficients of the x, y, and z, followed by the numbers after the equal sign. So x on the first equation didn't have any coefficient, but that means there's an invisible 1 there. So 1 followed by 2. And z has a negative sign, but no number. So that means there's a -1 there. Finally, there's a 3 on the first row. In the next row, we have 2. And then -1 again, because there's an invisible 1 always next to the y, and then finally there's the 2 with the 6 near it. The third row has x, which means there's 1x there, -3y, 3z, and finally 4. To finish the process, we'll add the square brackets at the beginning and the end, and the little line to indicate where the equal sign used to go. So my equal used to be here. the numbers in the first column represent the x coefficients and the y coefficients and the z coefficients for the other two columns respectively. The 364 represents the numbers that were found after the equal sign. So that's basically how you take a system and turn it into an augmented matrix, but it's also helpful to know how to do this the opposite way. So how do you take a matrix like this one that we have here and turn it back into a system of equations? We'll do that next in example 2. So as you can see here, we have an augmented matrix. We actually have two of them, and we're supposed to translate those into systems of equations. So I'll write the first matrix, 1 with -3, then -5, then -2. And the second row has 2, -5, -4, and 5. Finally, it's a -3, 5, 4, and 6. So that is the original augmented matrix that was given to me, and I need to translate this into a system of three equations with three unknowns. The nice thing here is I get to pick the letters I want to use for my variables, so I'm going to pick x, y, and z. Remember, this is where the equal sign used to go, and these are the numbers that go after the equal sign. So for my first equation, I'll have 1x, or just simply x, minus 3y, minus 5z's, equal to -2. That's the end of the first equation. Second equation, we'll have a 2x minus 5y minus 4z equals to 5. And finally, the third equation is -3x plus 5y plus 4z equal to 6. So that's how that works. So as you can see, we start off with 3 rows, 4 columns, and we end up with 3 equations at the end with 3 variables in them. So I want you to pause the video at this point in time and see if you can translate the next problem from a matrix into a system, and I'll give the answer in a few seconds. I'll give you a chance to pause here and figure it out for yourself first. So as usual, we get to pick our own favorite variables. I'm going to pick x, y, z, but you can pick a, b, c, w, x, t. It doesn't matter what you want. It's, as a matter of fact, it is random completely. I'm going to pick x, y, z, though, for this particular problem again. So for the first equation, I'm going to have 1x, which means x, and then -1y, which means -y. 1z, so I'm just going to write the z without the 1, and we have an equal 5 at the end. The second equation is going to be 2x minus y plus 3z equals to 1. And finally, the third equation is 0x, so I'm not going to bother writing it down, but we just have 1y, which is y, 1z, which is z, equals to -9. So the third equation is missing the letter x, but that's okay. That's the way it was given, and that's the end. So now you know how to take a system and turn it into an augmented matrix, or go from an augmented matrix back into a system. And this is a useful trick because we will be using the calculator next to solve a lot of these systems. So in the previous section, we used the elimination method or the substitution method or the graphing method to solve these types of problems. But now we can actually use the TI calculator to do the same process, or to do even faster process, including matrix, row reduced echelon form, and so on and so forth, to get the solution for the system without having to go through every single detail. Okay, so that will be the next page. So how do you turn that system of equation into a useful thing and get some answers for x, y, and z from it? Well, it involves doing something called row operations, and the legal row operations that you're allowed to do are interchanging two rows. So if you have a matrix, you're allowed to take a second row and put it on top, or take a top row and put it on the bottom. So in other terms, if I wanted to, I can take this row and write it on top, or take that first row and write it in the middle. This is legal. It just means we're reversing the order of the equations. It shouldn't affect the solution of the problem if we write one equation before the other one. So that's allowed. The second thing we're allowed to do is row scaling. So what does that mean? Row scaling means that we can take one of these original equations and multiply it by a random number. As long as the number is not 0, that should be perfectly fine. And we saw that when we were doing elimination. we were able to multiply one equation by some random number so that the x's, for example, cancel out or the y's cancel out. So that's called, in the matrix world, row scaling. And finally, the last thing you are allowed to do is row addition. And what row addition is basically you can take any matrix row, multiply it by a random number, then add it to another row. This is perfectly legal. It's basically like the same steps that we did when we were doing the elimination method. You take an equation and you multiply by a random number, then you can add it to the other equation, and that doesn't change the solution of the problem. Turns out that you can do something similar to that in the world of matrices, and it kind of makes sense that this is perfectly legal. So for the first problem on this page, example 3, I'm going to show you how to do all the operations by hand, but eventually we want to get something called a row echelon form from the calculator, because you'll see the process doing it by hand may be a little bit confusing, but I'll just demonstrate what the calculator is doing behind the scenes so you can appreciate what that tool is doing for you and what kind of math it's able to do that you don't have to do yourself. The whole point of row echelon form is to take a matrix with a bunch of random numbers like 2, 3, 8, 1, -1, 4, so this is an augmented matrix, and turn it into a matrix that has basically a 1 in the first row, first column, then 0 underneath that, some random number in the second column, first row, some random number there, and 1 again here, and some random number as well there. So this is the goal of the problem, is to basically get 0 in the second row, second column, and 1s on what we call the diagonal, and everywhere else we just want random numbers. The calculator is able to do that, but I'll go ahead and do an example with this matrix that's provided with this example so we can see and appreciate what the calculator is basically going to do for us later on. So to do this, let's begin by first writing down the system as a matrix. So the system that was given to us is 2x and 3y equals to 8. Then x minus y equals to 4. I'm going to turn this into an augmented matrix with 2, 3, and 8, followed by 1, -1, and 4. So all I'm doing here is I'm extracting the numbers for x, y, and z, and putting a little slash where the equal sign used to go, then putting the numbers that I found after the equal sign. So ideally, I want a 1 to be where the 2 is right now. So I don't have a 1 there, I have a 2, but I want a 1. So what I'm going to do is I'm going to tell myself, let's interchange, let's remove the row 2 and replace it and put it into row 1. So row 2, that's why I'm writing R2, is going to become row 1 in the new problem. So I'm going to swap these two rows. So 1, -1, 4 is going to be on top. Then 2, 3, and 8 will go underneath. So we're swapping or interchanging the rows. So typically we like to write this little arrow thing and describe what we're doing on the side, then write the solution next to it. So all I did here was take row 2 and interchange it with row 1. Okay, so now I have a 1 there, which is awesome. That's what I want. The next thing I got to do is turn the 2 into a 0. And to do that, that involves multiplying the first row by some random number and adding it to the second row. So for example, if I were to multiply this number here by -2, then 2 and 1 multiplied with each other will be a -2. And if I added with that number underneath, then I'll have a 0 appear there. So the idea is we're going to take the first row, multiply by -2, then add it to the existing second row, and we're going to put the whole answer back in the second row. So this is a lot to digest. So again, let me explain it one more time. I want a 0 in this spot. How can I get a 0? I'll have to multiply another row, which is this guy, by some random number, then add it to get a 0. So the only number I can multiply 1 by and add it to 2 and get a 0 at the end has to be -2. this is where this initial -2 is coming from. So we multiply this guy by -2, then when we're done with the product, we will have -2. We add it to this guy, and where do we write the answer? We write it in row 2. So row 1 is not changing, so we're going to keep 1, -1, and 4 there. But now we're going to rewrite row number 2 with brand new numbers that come from doing this row operation. So let's see. I need to multiply the top number by -2 and add it to the bottom number. So -2 times 1 will be -2. Adding it to 2, I get 0, which is exactly what I wanted to see. Then I need to repeat the same process again for the second entry. Because we did it to the first one, we take the second entry, we multiply by -2 and add it to the number underneath. So -2 multiplied with -1, and we need to add it to the number 3. And whatever result we get, we're supposed to put it into the second row. So -2 times -1 will be 2. 2 plus 3 is going to be 5, and that's my new number in row number 2. And again, we do the same thing again on the third number. We multiply it by -2, and we add it to the number underneath. So we are going to multiply -2 with 4 and add it to the number that was 8. So -3 times 4 will be -8. 8 and -8 will be a total of 0. And so that's the end of step number 2. I'm going to erase everything because it's no longer required. These are all basically done in pencil typically, and when you're done, you should see 0, 5, 0 in the bottom row. Now, the last thing we need is to have a number 1 where the 5 is currently. So to get a number 1, it involves taking the row and dividing it by or multiplying it by some random number. So in this case, I want the 5 to become a 1, so I'm just going to take the numbers in row 2 and divide them by 5. And where am I going to put the answers? I'll put them back into row 2. So meaning row 1 is going to stay the same, but every number in the second row is going to get divided by 5. So including the 0, I'm going to divide by 5, it's going to be 0. 5 divided by 5 is going to be a 1. And finally, 0 divided by 5 is going to be 0 yet again. So the numbers are going to be 0, 1, 0. And that's the end of the process. We have turned our augmented matrix into the row echelon form. Okay, so that's what we call this. A row echelon form is the process that gives us 1, 0, 1, and then random numbers everywhere else in the matrix. And typically, that's how it's done by hand. Now, why is this useful? This is useful because now I'm able to read from here the answers to my problem. So remember how we can take an augmented matrix and turn it into a system? And we can do that now as well. So what is this saying? This is saying that we have a system of two equations where the first equation is x minus y equal to 4. And the second equation where we have 0x, I'm not going to write it. We have 1y, I'm not going to write the 1, I'll just write y equal to, it seems like the number should be 0. So this is telling me right away that y is actually equal to 0. So we actually have one of the two missing values. We already got what y should be. So all we have to do now is find the x value. So if I have y, I need to find x. It's very straightforward. All I have to say, but wait a second, I remember one of my equations was x minus y equal to 4, and I just discovered that y itself is supposed to be 0, so x therefore has to be equal to 4. And that is the end of the problem. We just got x and y by doing this row echelon form thing. So the solution of my system is the numbers x, y, where x is 4 and y is 0. So this is pretty cool. You're not going to be required to do this by hand. I just want to do a demo for you to show you what the calculator does, what's it capable of, but this is now how you're going to do problems where it asks you to solve a system of linear equations. You can do elimination, you can do substitution, you can graph the system, or you can now use matrices. So that's the beauty and the power of matrices. This is why we spent a little bit of time learning how to multiply, add, subtract, and so on and so forth with matrices. But from this point on, I'm going to use my calculator to solve every problem. So let me show you how I would have done this with a calculator. So let's turn on our TI calculator and enter in this matrix that was given to us in this problem. So once you turn on your calculator, you'll need to enter the matrix menu, and I'm going to go ahead and edit matrix 1, which is matrix A. I need to tell it the size of the matrix. We have 2 rows and 3 columns in our augmented matrix. Then we'll type in the numbers 2, 3, and 8 for the first equation. We also had 1, -1, and 4 for the second equation. So those are the equations of my problem. That's the augmented matrix. Once you've typed it all in, you're going to go ahead and quit this whole thing, go back to the main screen of your calculator, and once you're there, re-enter the matrix menu by clicking second x-1 button. This time we want to do some math on this calculator. We want to use the matrix math menu, so we enter the matrix menu, then we move 1 across and we see a list of options. There's DT, there's other words in here. We want to scroll to find the one called REF, which stands for row echelon form. I find it faster to use my up key and go from the bottom up, and there are options A and B. For now, I'll go ahead and use option A, which is the row echelon form. So once you find that on your calculator, it should be option A. Click enter. That will put REF on the main screen of your calculator. Make sure there's nothing before it because it will mess up the answer. And I'm going to basically command the calculator to do the row echelon form for the matrix that I care about. In this case, the matrix is called matrix A. So re-enter the matrix menu, put 1, and then close the parentheses. So this is saying to the calculator, I just gave you some numbers, and I put them in matrix A, and I want you to row echelon form for me. And when I click enter, we see some random numbers here, 1, 1.5, and 4, 0, 1, and 4. And so again, from this, we can see that the calculator has slightly different numbers than my answer, but it shouldn't matter. We should be able to get the same solution. So let me go ahead and write down what I did. I put 2, 3, 8, then 1, -1, 4 into my calculator, and I called it all matrix A. Then I told my calculator to do row echelon form of A, the matrix, and it gave me the numbers that we saw on the screen, which were 1, 1.54, 0, 1, 0. And so from this, we can now extract some information. Remember, this was an augmented matrix. The calculator does not put the little line, but we can tell from this bottom row that y should be equal to 0. That's what we can see from here. Remember, because the first column represents x, the second column represents y, and the third column represents just the random numbers that were after the equal sign. And once we have that y is equal to 0, we can use our first equation, which consists of x plus 3 over 2y equal to 4. And it's telling me that x plus 3 over 2 times 0 is in fact 4. 0 times anything is 0, so this is saying x is equal to 4. So we get the same result that we got earlier, but using the TI calculator, it's a little bit faster because you don't have to go through all the middle steps. Now, if you want the 0 and the 4 without doing all of these extra steps by hand, then what you could do is use your TI calculator, but instead of clicking REF, use the other option. So I'm going to go back to the matrix menu. I'm going to go to math, and I'm going to go from the bottom up. So using my up key, I'm going to select the option called RREF. So this does extra steps that we're having to do by hand. And the calculator now will be able to give me the final solution. And as you can see, it says on the screen 104010. So from the second line, we can read that y is equal to 0. From the first line, we can read that 1x, 0y is 4. So that means 1x is 4, meaning x is 4. So that's how you do this with the calculator. And from this point on, I'm just going to use the calculator for every problem remaining in this section. The steps for putting all this into the calculator and seeing the REF form are written here. So pause the video if you want to copy them or take a screenshot. Or if you already memorized them, great, good for you. You don't have to do anything. You just keep moving on to the example number 4. Now, this process is called Gaussian elimination, but on the exam, you don't have to use Gaussian elimination. If you like elimination, you can use that. If you like substitution, you can use that. So just be ready that if you hear the word Gaussian elimination, it just means that we want to see some matrices on your work, for example. So let's see. Example 4 gives us a matrix, gives us a system which is 2x plus 3y equal to 6, and it gives us the x minus y equals to 1/2, and it's asking us to solve this system using this new method. So the first thing I want to do is make sure that everybody's all lined up nice and pretty. All the xy's are lined up, all the numbers after the equal sign are lined up, and I'm going to turn this into an augmented matrix. So I'm going to call the augmented by the name A, and I'm going to put the numbers that I saw in the problem into this A matrix. So for the first row, x has the value 2 in front of it, y has 3, then the number after the equal sign is 6. In the second row, I have 1 for the x, even though it's invisible. I have -1 for the y, even though it's invisible. And finally, I have 1/2 after the equal sign. So that's my matrix. And what I'm going to do now is ask my calculator to find the row echelon form of the matrix A. So first, type in the numbers, then do REF on your calculator to see if you get the same thing that I'm going to get in a second. Okay, so I just finished typing my numbers in, 2, 3, 6, 1, -1, and 0.5. And once you finish editing a matrix A into your calculator, we're going to quit. Then we're going to go into the matrix menu again. This time we want to do some math. So move over to the math column. Then from the bottom up, let's look for REF. And so this is asking for the row echelon form. And we'll type in the name of the matrix next. And then we'll hit enter. So I'm seeing some numbers. Let's go ahead and take them to our work. 1, 1.53, 0, 1, 1. I personally don't like writing decimals, so instead of 1.5, I'll go ahead and write 3/2. It's the same thing as 1.5, but this is a little bit better. So remember, the first column represents the x's, the second one is the y's, and then these are all the random numbers. And so by reading the second line in my matrix, by reading the second row, I can see that it says 0x and 1y equals 1. Well, if I get rid of 0x because it's 0 and I don't need the 1y, I could just write y. This is telling me directly that y is in fact equal to 1. And once I have y, all I need to do is look for an equation, any random equation in my problem. We don't have to use a matrix one to get the x. So I'm going to say, but wait a second. Remember that this equation over here was 2x plus 3y equals 6. And I just discovered that y is 1, so that should be helpful because I can find x next, right? So y is 1. I'm replacing the y with the value 1. So what would I get? I would get 2x plus 3 is equal to 6, which means that 2x is going to be 3, which means x is 3/2. And that is the solution of the problem. X is 3/2, y is 1. So my solution is the ordered pair xy with the numbers 3/2 and 1. Okay, but like I said, this is not the only option. If you want, you can do extra work on the calculator, so you don't have to do all this extra work by hand. So let's see that next. on your calculator, instead of clicking REF, enter the matrix menu, go to the math column, and use the row. So RREF, it's the reduced row echelon form. So let's click option B in, tell the calculator to do this work on the matrix A that we are interested in. And what I'm going to do this time is I'm going to click math 1 to take every answer that I get, if it has decimals, and turn it back into a fraction. This way we can avoid decimals. We don't really like decimals in math, and this will circumvent that. So if I click enter, you can see from what's on the screen, the first row is 103 half. This is saying 1x plus 0y is 3 halves. So this is saying x is 3 half really, which is the same thing we got by doing the work by hand. The second row of this matrix says 0, 1, 1, which is basically saying that 0x and 1y, so in other terms just y, is equal to 1. So that's the benefit of using RREF versus REF. And all this is what we call in math the Gaussian elimination. So I want you to pause the video here and try to take this system of equations, turn it into an augmented matrix, and use either REF or RREF on your calculator to get x and y. I'll give you a few seconds here to pause the video, and we'll look at the answer next. Okay, so the matrix is 4, 3, 11, 1, negative 3, negative 1. And what I'm going to do next is try to row echelon form it. So I'm going to go to the math menu, go up from the bottom, and click option A. Then I want to tell the calculator to do that on the matrix A. If there are any fractions, I want you to turn them to fractions instead of decimals. And there we go. So you see 1 3/4 11 over 4, 0, 1, 1. So from doing this, we get basically the y for free. The bottom row here is 0, 1, 1, which is saying 0x plus 1y equals to 1. So the y is already 1, but we have to do extra work to get the x. Well, I don't want to do the extra work, or maybe you don't want to do the extra work. So what is the solution? What's x and y? If you want to get that with the calculator, you'll go back to the matrix menu. You'll go to the math column, and from the bottom up, look for row reduced echelon form. So RREF, then put the matrix name, which is matrix 1, close the parentheses, and then I'm going to click math 1. And this way, if there's any decimals that will appear on my screen, they will be turned into fractions instantly. That's why I'm adding the little frac command at the end. And when I do that, I can see 1, 0, 2, 0, 1, 1. So that's going to give me the x and y instantly. The first row is saying 1x, 0y is equal to 2. So 1x is 2. X is 2. 0y, sorry, the second row is saying 0 plus 1y equals to 1. So that means y is equal to 1. And that's it. We're done. Okay, so this is, again, a reminder, a consistent independent system. It's consistent because we got one answer consisting of the numbers 2 and 1. And it's independent because there were only one single solution. The solution was the pair 2, 1. All right, perfect. So we can do this for even 3 equations with 3 unknowns. So a good practice for you is to pause the video here and figure out what the row echelon form of the matrix is, and then the reduced row echelon form, and then do that again for part B of this problem. I'll give the answers on the screen in a few seconds with that explanation. Okay, so for my example, the numbers that I'm supposed to have in my matrix are 1, negative 2, 3, 9, negative 1, 3, 0, and negative 4, and 2, negative 5, 5, 17. So you just have to be careful here because the middle row does not have a z variable. That means that the number should be 0 there. And I'm going to put all the numbers in. I've verified already that all my x's are lined up, all the y's are lined up, all the z variables are lined up, and all the numbers after the equal sign are all lined up. So Once you've lined them up, it's pretty straightforward from there to put them into your calculator. Just make sure all the numbers are correct. Make sure you're using all the tiny little negative signs. And once you're done, you're just going to quit this whole thing and type in RREF. Find the matrix name that you used. I used A. And I'm getting a bunch of zeros, some ones, and then some random numbers at the end. So let me write down the numbers: 1, -1, 2. So the numbers that I found were 1, -1, and 2. Let's just confirm one more time that the numbers were 1, -1, 2. Perfect. And so what does this mean? What can I do with this information? Well, from reading this last row, I'm reading 0x plus 0y plus 1z is equal to 2. Well, all these extra zeros don't matter, and the 1 doesn't have to be even written down, so that's saying that z is the number 2. So that's it. That's the end of the last row. The middle row is telling me 0x plus 1y plus 0z is equal to -1. Again, the 0x doesn't matter, the 0z doesn't matter, and the 1 doesn't have to be written down, so this is just saying y is equal to -1. And in the same way, I can see that x itself is equal to 1 as well. And there we have it. The solution is the tripled xyz with the numbers 1, -1, 2 as the answer. Okay, so that's the end of the part 1. And finally, we get to the last one. And again, take a minute to pause the video here, see if you get the same values that I'm going to get.